Good evening. Today's class, what we are going to see, it's about substitution of refractive index. Those of you who have learnt about refractive indices and in the previous lesson we had discussed about all this, but then today's class is it is focused on how to substitute the correct angle in a refractive index formula or Snell's law. Now, why would I insist on this is recently we had our mock examinations and there was one question where there were different angles given and majority of my students, kind of struggled to do the correct substitution. Now, in this class, I'll show you an easier way or a trick to remember to substitute it correctly. I know in higher classes you will learn about, relative refractive indexes and all, but then for IGCSE level, to substitute the angles correctly and get the refractive index value correctly, I'll teach you an easier method to remember. All right, let's get into the lesson. Now, in the start of the lesson, or when you start to learn about what is refractive index, you may have learned about it is the ratio of how fast, or by how much the light ray slows down in a medium is what refractive index is all about. Now, you may also know about three formula. One is sin I over sin R. The other one is 1 over sin C, where C is the critical angle. So if critical angle is known, it's very easy. You just directly substitute into 1 over sin C. Another formula is speed of light in vacuum upon speed of light in medium. All right. Now, I'm not touching the other two formulae. I'm just looking at this formula and then teach you how to do the correct substitution, right? Now, when you start to learn, this would have been the picture that's that you would commonly come across in textbooks or in your notes. Your teacher would have taught the angle between the normal and the incident ray is angle of incidence, and the angle between the normal and the refracted ray is angle of refraction, and that's what you will substitute here. It's a straightforward calculation or substitution. There is nothing to go wrong, or you don't have to think much about it. But then when it comes to situations slightly different, then the substitution matters. Okay. Now here also you have got here the incident ray is here, incident angle is here, R is here. Find similar substitution, right? What about this one here? See, here the light is leaving the block. We have got an angle here. We have got an angle here. Now, under normal, like if you're not paying attention to the light ray from where it is coming from, you may have a tendency to take this angle as I and this angle as R. Right? That's a common mistake. That's what I was about to, when I started the lesson, this is what I wanted you to think about. Now, it will be a confusion. When you see the arrowhead, you tend to relate that angle to be angle of incidence. When the light ray is leaving, then you will tend to remember that as angle of refraction and you substitute. So my advice to you would be, if you are taking n of a medium, right, then what you need to remember is sin I is as it is. You don't have to change anything, but sin R, you remember it as that angle should be inside the medium. Now this formula will definitely help you to avoid any kind of mistakes. I repeat, now n of medium if you take, that is refractive index of a particular medium, if you're either calculating or you're substituting, whatever may be the case. Now sin I is measured in one particular medium, but then the R, the denominator angle that you are measuring, must be inside the medium. So these two must be the same. All right. Now there was one question before, I think it was in 2007 or so, the refractive index of air was given. So there was like a little confusion. Again, most of the students went wrong because usually we substitute n of glass or n of water. But here when n of air was substituted, then you should have the angle in the air substituted here. All right. So as I said, if you remember this as a formula, you will not go wrong in your substitution and calculation. All right. I repeat, now if you take refractive index of glass, then the angle inside the glass should be substituted in the denominator. Okay, so coming to this situation here, if you have substituted n of glass here, this is a semicircular block, glass block. So if you take that refractive index, then this angle must be inside the medium. So this angle needs to be substituted. That will be your R and this will be your I. You get what I'm saying? Okay, so though the direction is into, it is coming towards here, the normal. As I said, you may have a tendency to substitute that as I and R. You may go wrong in that. But then, what's the correct substitution? I is where? In the outside medium. It's here, but R is inside the medium. Okay. Now see, let's think about another different situation. Say if you have one interface of water, the other one is a glass. You have the light ray coming in and it is, okay, this is the diagram. Now you have got two angles here, one angle here, one angle here. Now say n of refractive index of water is known to you. N of water is known to you. So which one will be I, which one will be R? How will you substitute? This will be equal to sine and sine. Say this is 40 degrees and this is 30 degrees, which should come in the numerator. As I told you, if you're using this, if you remember this, N of water, so the angle inside water should be in the denominator. So 40 should come in the denominator and 30 should be in the numerator. So do you understand what I'm saying? So the substitution for this, as I said, if it's a straightforward one like this, you don't have to bother about, you will not make mistake. As I told you, my students, when they were like 4-5 angles, I think there were 4 angles given in the mock examination paper, and they found it, most of them, messed up in substitution. So I thought I should give them a tip along with that. If anyone else is watching, you may also benefit from it. Remember, this N of medium and angle of refraction should be in the denominator. So this trick, if you remember, I hope you will not go wrong in these substitutions and get the answers correctly. All the best for your examination. See you in another video. Bye.